right, welcome to the Explainer. Today, we are diving into what might just be the single biggest bet in the history of tech. I'm talking about OpenAI's plan to spend $1 trillion. Yeah, you heard that right. And the big question is, why? Well, it turns out they're trying to solve a problem that's already costing them billions. So let's just start with a number that is kind of hard to wrap your head around. $5 billion. That's how much cash OpenAI reportedly burned through last year. I mean, think about that. The company behind ChatGPT, literally the most hyped up tech on the entire planet, is just bleeding money. Which, leads to a pretty obvious question, right? How in the world is that even possible? Well, the answer isn't really about their software or some flawed business model. Nope. It's all about the hardware. The incredibly expensive, super power-hungry chips that are the actual physical foundation of AI. And that really gets us to the heart of the matter. The AI revolution, you see, it's got this insatiable appetite for computing power. It's like a beast that never stops eating. And feeding that beast has turned into this massive financial and strategic headache for pretty much everyone in the game, but especially for OpenAI.
I mean, just think about it for a second. Every single time you type a question into ChatGPT, or every time they train one of these giant new models, it's just gobbling up an insane amount of computational power. We're not talking about running a simple app on your phone here. This is more like firing up a global network of supercomputers and running them full tilt 24/7.
Okay, so this pretty much says it all. You can see there's a serious chokehold on the market. To get the kind of specialized power they need, all these AI companies have been almost totally reliant on one single company, Nvidia. Their GPUs, or graphics processing units, are the gold standard. And while that's amazing for Nvidia, it's created a huge bottleneck for everybody else. And having a bottleneck like that, it creates some major headaches. We're talking sky-high prices for the chips you need, waiting forever because there aren't enough to go around, and, maybe worst of all, a massive strategic vulnerability. Let's be real, when your entire business relies on one supplier, you're not exactly in the driver's seat, are you? So, what's a company like OpenAI supposed to do when they're facing this, mountain of a problem? They decided to flip the whole board. Instead of just buying chips off the shelf, they said, you know what? We're going to build our own. Custom chips designed from the ground up just for them. But here's the thing. They're not the first to have this idea, not by a long shot. They're actually following a playbook that was pretty much written by the other tech giants. You had Google doing it years ago with their TPUs, their tensor processing units. Amazon did it with their Trainium chips. They all hit the same wall and realized, hey, to get to the next level, we've got to control our own hardware. OpenAI's big partnership with Broadcom, it's really just the next logical chapter in that same story. And the scale of this thing, it's just immense. We're not talking about making a few thousand chips here and there. No. The goal is to build an entirely new infrastructure, starting with 10 gigawatts of their own custom AI accelerators. That is a mind-boggling amount of computing power, all of it perfectly tuned for what OpenAI wants to do. Okay, so how does this actually work? I mean, how do you go from a bright idea on a whiteboard to a real, physical, state-of-the-art chip that could literally power the future of AI? Well, it's a super complex journey that takes years. So first, OpenAI's team designs the blueprint, right? They architect the chip to be absolutely perfect for their AI models. Then you get to this make or break moment called tape-out. After that, the design gets sent to a master craftsman, basically a manufacturer like TSMC who physically makes the chips. And if everything, and I mean everything, goes according to plan, they're hoping for mass production sometime in 2026. Let's zoom in on that term for a second, tape-out. You really need to understand this. It's the absolute point of no return. The best analogy is sending the final version of a book to the printer. Once you hit send, that's it. Any change you want to make after that point is going to be unbelievably hard and cost you millions and millions of dollars. So yeah, it's a super high-stakes moment. You better be sure you got it right.
So what this all boils down to is a really crucial trade-off. On one hand, you've got the off-the-shelf chips from a powerhouse like Nvidia. They're amazing, they're ready to go, but they're built for general-purpose work. On the other hand, you have these custom-built chips that cost a fortune and take forever to make up front, but, and this is the big but, they can be perfectly optimized for exactly what you need. That means way more efficiency and, eventually, a much lower cost for each chip, but only if you're operating at a crazy scale.
And this is where we really start to see the true scale of OpenAI's ambition. And honestly, it's a little hard to wrap your head around. See, this isn't just about saving a few bucks on chips in the long run. Oh no, this is about building the entire foundation for what they see as the ultimate prize, AGI, or artificial general intelligence. And building that, well, it comes with a price tag that is just astonishing. Remember that 10 gigawatt number we mentioned? That's just their initial goal. To try and put that into perspective, just 1 gigawatt of this stuff can power what's equivalent to millions of today's top-of-the-line GPUs. It's a staggering amount of power. Okay, now let's talk about the cost, because this is where it gets wild. Industry folks are estimating that the full cost to build everything out, we're talking chips, the buildings, the power, the cooling, the whole shebang, is around $50 billion. And that's per gigawatt. I mean, that figure alone is just incredible. So, you take this chip deal, you add it to some of their other massive infrastructure commitments, and suddenly you land on a number that is just jaw-dropping. We are talking about plans that add up to roughly $1 trillion in new spending. That's not just a lot for a tech company, that is one of the biggest infrastructure projects in human history. And just when you think, okay, $1 trillion, that has to be the ceiling. Nope. OpenAI's CEO, Sam Altman, has basically said that even that might just be the down payment. He's thrown out numbers like $5 or even $7 trillion as what might ultimately be needed to build out the full infrastructure for truly advanced AI. It's just on another level. Look, when you're talking about that kind of money, it's guaranteed to create some massive waves. This isn't just about one company fixing its supply chain anymore. This is about completely redrawing the competitive map for the entire tech industry. A new conflict is heating up, and you could call it the new chip wars. So let's take a look at the key players on this new battlefield. You've got OpenAI, they're the super ambitious customer driving all this demand. Then there's Broadcom, the expert design partner who can actually make it happen. You have TSMC, the quiet giant in the background, who is the only one who can actually manufacture these things for pretty much everybody. And then you have Nvidia, the reigning king, who is now suddenly facing a huge challenge from its own biggest customers. The dynamic has totally changed. But let's be crystal clear here. This is a monumental gamble. I mean, there are so many ways this could go wrong. First, there's a very real risk of technical failure. Designing a brand new chip is notoriously difficult. Then there's the financial side. A $1 trillion bet could absolutely crush the company if demand for AI slows down. And maybe the scariest risk of all, the technology is moving so blindingly fast that the chip you spend years designing today might be totally wrong for the AI models we have in, say, 2027. So, what's the big takeaway here? What we're witnessing right now is a historic race to build the physical brain for artificial intelligence. The new power struggle isn't just about who has the cleverest algorithms anymore. It's about who controls the actual silicon, the power plants, the physical infrastructure that it all runs on. And that leaves us with a really critical and maybe kind of scary question for the future. As this powerful new intelligence comes online, who's really going to be holding the power?